Welcome to School of PE podcast. I'm your host, Chris Miller, and I'm so glad that you could join me this week. We are going to discuss topics about FE, PE, and SC, and we're also going to answer questions that will help students prepare for their exams. Let's get started. Hello, everyone, and welcome back to another exciting episode of the School of PE's weekly podcast. I'm Chris Miller, and today I got a special guest with us here, Mr. Charles Hubbard. His first time on the show, so let's welcome him aboard. Charles, thanks for coming on, and before we get into things, maybe you can tell the audience a little bit about yourself.
Yeah, thanks, Chris.
Sure.
I've been working for Braun Intertech, a professional consulting firm for something on the order of 33 years, and I had 5 years of experience with a couple of firms out on the West Coast before that. And I think for about the last 15 years or so, I've been mostly involved in flood protection projects, landslides associated with oil and gas in Western North Dakota, that sort of thing. So that's kind of become a little bit of my niche. And I do a lot of process and practice work for the company in terms of setting the standards for our engineering group.
Very nice. Well, again, hey, it's great having you here. Hopefully you had a great Thanksgiving holiday and back into the swing of things.
I did. Thank you.
Sure. So where are you out of, Charles?
Currently, I'm living in Grand Marais, Minnesota. My company's headquarters is in Bloomington, Minnesota. And we have offices that pretty much cover the 35 corridor, from work as far as Western North Dakota. We have offices as far as Western North Dakota, throughout Minnesota, Iowa, Kansas City, and Texas, Oklahoma, a little bit on the Gulf Coast. So that's kind of our region. And we have a lot of, groups that handle things operationally between there. Most of my work actually has been in North Dakota for the last decade or so. So I travel a lot.
Yeah, man, but a lot of cold you're in North Dakota. I grew up 2 years in North Dakota. Minot, North Dakota. My dad was stationed out there, and all I remember is it was cold.
Yeah, we're doing our third phase of flood protection in there since the 2011 flood event.
Oh, wow.
So there's a lot of work going on there right now.
Well, hopefully you guys will avoid the winter.
Can't do that. Just wear another hat.
Yeah, I remember it's cold. So we have an interesting topic today. We're going to talk about technical competency in the real world. So, let's kind of jump into that. And so, people might be wondering what in the heck does that even mean? So if you could maybe give a nutshell version or maybe a more in-depth version what is project competency?
Yeah, this is part of I selected this just because we can all discuss technical things that, we're good at. We want to learn how to calculate something. But I did this for the benefit of our engineers in training and those that are project engineers looking to become a PE. Basically, the competency is defined by the Oxford Dictionary. I've got a few of my slides from my presentation here. A speaker's subconscious intuitive knowledge of the rules of their language, often contrasted with performance. And so it's really not just about understanding how to use the tools that you have technically, because you can do that poorly, or you can use the tool well but apply it in the wrong situation. So what we're trying to do is to understand what's important and know how to apply what we know to different situations, because you're constantly being presented with a new problem that requires a different set of parameters. You might be put into a new venue, a different environment geologically. So what you know is a small portion of what you need to be able to do, and that's really what that's all about. Is approaching things carefully so that you go through your process and do things consistently in the best way possible, completely as possible, to solve the problem with limited mistakes, right?
Short and sweet. I like it. So, you hear about several different types of competency, right? So you have your project competence, technical competence. How do those two differ?
Yeah, well, technically, it's really just again knowing how to use the programs. Knowing how to do a calculation. How do you compute the seepage force in an embankment? And the process competency would be understanding a little bit more about potential failure mode. So we know what seepage can do and we can analyze it, but where do we look to find where it's going to be a problem? And how important is it in a given situation? The other thing is, we can have our toolbox with us to be prepared to solve a problem and do some calculations, but we might not have the information we need to apply those tools correctly. I have a project example where was called out to look at an oil pad, and they thought there was a landslide that was occurring because the pad had a crack going through it and there was some subsidence. But we started looking around and realized that it looked more like subsidence or loss of material through some voids or something different. And I was asking questions. Well, who knows something? Who took some pictures? What happened during construction? And so finally, at some point, a few weeks later, somebody sent a picture where they showed how they had dug 30-foot wide trench, 10 feet deep, all the way through the pad, and they put a bunch of huge boulders in there that they had excavated out from a slope, and then kind of buried that. Well, that's what was, particles were migrating into those rocks, and so they had some subsidence years later. But until we had those facts, we weren't really able to apply the tools that we had because we didn't know what the problem was. So that kind of situation where you can think about what questions to ask, what might have been going on, that's the difference there is part of that intuition, discovery, experience, that sort of thing, knowing how to handle the problem.
That makes sense. So, when it comes to competencies or shortcomings, I guess there's ways that you can maybe improve or enhance, right? So you look at technical or even skill competency. Let's say, let's take a sport example, and then let's say you're a basketball player and you can't dribble with your left hand. So what you might want to improve, you might, practice dribbling with your left hand and only your left hand, or doing some separate drills. So those are some easier ways to address competencies. But how can an engineer improve project competency?
Yeah, it's experience, and the way to accelerate that, use your experience in the way to maximize your growth, is to be asking questions, is to be learning from not just others, mentors, people in your own firm with similar experience, like geotechnical engineering. It might be asking contractors when you're a technician, asking contractors, how do you use this equipment that you use, and what happens, when you have excess moisture in your soils or trying to get compaction. Learning how other people do their work helps you understand, because there's sort of a joke, you go out to a site and everybody says, oh, the engineer showed up, right? And they think you're kind of this dummy, that you're technical. You come out here and you crunch numbers, but you don't understand anything about what they're doing. And you kind of don't. I mean, if you're all theoretical, you need to understand, how things are built. And then, and that varies region to region. People use different equipment in different areas. You can't have the same expectations. So learning, and when you're out with another engineer, you get a chance to participate on a project reconnaissance or something. Ask questions. Don't just follow the person around and have them tell you what they do or tell you what happens. What's going to happen in the next situation. If you were the one sent out to the next site and there were some things that were different, what would you do? How would you handle that? So it's really just gobbling up, everything everybody knows that you touch in your projects. And it's very important to, understand construction and talk with structural engineers too, have all that knowledge. The more you know about what other people know and how they do their work, the better you'll be. And, getting to the education point, the more you share about what you do and how you do it, then you start having these symbiotic relationships with people with other disciplines. And now you can speak each other's language and understand how you work together, to get things done.
I 100% agree with you. I mean, asking question is a great thing. Sometimes you have someone that, like you said, maybe you're shadowing someone on a job site and you're just simply following them around. You might be, kind of engulfing what you're seeing being done, but without asking questions, you don't know maybe why something's being done or how something's being done. So I think asking questions is key.
Yeah. Another thing, excuse me, is that it's also up to the mentor or the person doing that, leading that effort, to check in too, not just assume that the person is learning something. I've had two people out on projects recently with me, and one of them, we got done, and I was surprised that this person said, "Hey, don't leave yet," because we were in separate vehicles. He said, "I have some questions," and I was really impressed by that, because you're kind of surprised, because most people don't ask questions. And then I had another recon where the person was with me and just kind of letting me do the work, and feeling pretty comfortable that I was addressing the problems, but wasn't expressing the same kind of interest in becoming me, you know what I mean, or learning,
Right.
and was on the phone sometimes and things like that. So business wise, not with their family, but it's important, if you want to be functioning at a higher level, then you have to pursue it.
No, I agree, and I agree too that it is a two-way street, right? I mean, even as the person doing the leader and the mentoring, they should also, kind of be aware maybe the body language or the lack of engagement from the person that's shadowing them to maybe take the next step and ensure that what they are learning is in fact, being, I guess, driven across. So,
Mhm.
we've been talking about competencies and things like that, but what are some of the qualities of a competent practitioner?
Yeah, and so this is basically, what does that person look like that knows this stuff, right? Yeah, so I had a slide to show, those people in my firm, and this is a person that seeks to understand. Like I said, I've been in the business almost 40 years. I'm still learning something all the time. I'm still coming onto sites where, scratching my head, I feel like I'm bumping the ceiling of my knowledge, and so I have to have a process in place that allows me to feel like I can handle it, and also be aware that I have vulnerabilities and weaknesses and gaps. So, we're looking to, we're understanding earth materials and their behavior, the role of geology and structural stability, and this is from a geotechnical perspective, of course, impact of construction on geologic materials, and it works both ways. What is the site going to do? Could the site do to your project, and what are you going to do to the site? It can fail both ways, but a person who's pursuing and gaining in both, process
Hmm.
skills and technical skills, training, practice, research, reading, tinkering, um, playing with stuff. It's not, the stuff you're using on a computer isn't gospel. It's helping you either visualize or numerically qualify something, but you still have to use judgment, to determine whether it's
Right.
reasonable. Having successes and learning from that, assessments, application, growing. If you're something else, you can either be, uh, uh, you can be apathetic about it. You can be unaware of the things that are going to get you in trouble,
Hmm.
and you're going to learn your lesson eventually by finding yourself into court, or something like that. Unbalanced. You're not complete. You don't understand these other disciplines. Careless, complacent, overconfident, inflexible, impatient, and distrustful. So, there's a lot of people that there's a sort of a phase of growth where you have 5 to 10 years of experience and you think you've arrived, and you do know a bunch of stuff, but then there's always going to be, every number of years, or as you move up into certain skills, a time when you get reset. Something happens and you're
Right.
like, oh boy, wow, I didn't see that coming. And if you don't think about that, then you're either going to retreat back and be an ordinary person working on those projects that don't kick you, or you're going to learn and grow and become better, and be reputable, and as a consultant and those kinds of things. So that's kind of what that's about.
No, I like it, and sometimes you're right. You learn a lesson in the hard way, but sometimes it's a difficult pill to swallow. Like you said, you can find yourself in court or even worse. We've all heard the term "wing it." Right? Like you kind of fake it. A lot of times, sometimes it doesn't come back to bite you in the behind, and sometimes it does. And we've all been there where maybe we've faked it or winged it to where, like maybe during a presentation, instead of having a prepared slides, you're just gonna kind of go off of memory or just kind of spew it and see how it goes. But when it comes to technical competencies, yeah, you can maybe fudge it or wing it, but there's got to be times, and maybe you've seen it, Charles, is where it's been where the lack of competency or the winging of it has led to maybe a dangerous situation or a life-threatening situation. Have you experienced any of that?
Uh, yeah, and now this is I'll temper that just by saying it's not like I saw somebody that was doing something really stupid or this was just idiotic or something, but it's just one of those things where, like in my business, in the certain market sectors, companies do things the way they do them, and so, for example, there's in oil and gas, there's thousands of miles of access roads. There's thousands of pads. There's thousands of, pipelines and things like that. So the percentage of projects that have problems is very small, because they have a system. They kind of know what they're doing. But at the same time, it's very important to spend, money only where, it's going to directly apply to your returns. And so doing a geotechnical evaluation on a in the Badlands area out in western North Dakota is typically not done. And so there, every once in a while, then, there's a landslide or something like that. And so, I can come onto a site and there's a water intake structure on Lake Sacagawea that was built right on the shoulder of a landslide. And, going out there at the time, some cracks showed up. I'm like, wow, you're really lucky. You either really smart that you chose this location because you're 10 feet away from disaster, or you're just really lucky. And so, I don't know exactly which, but when you come to a situation where now you're out there to solve a problem like that, it's much different. And in that case, we came up with some recommendations to analyze and evaluate, and determine how to if there was a need to make the structure safe. And in the meantime, as we went through that process, a very large slide occurred. Well, the landslide was already there, but it mobilized. And wow. I don't know, several acres, 15 acres of land moved over the course of a couple of days, maybe 100 to 100 feet a day, kind of a thing. And so, you get a call, you're 10 hours away, you got to come out here, the ground is moving and our building's at risk. And, what are you going to do? So, we show up and, everybody's looking at me like, tell us what to do. And you've got the soil beginning to pile up and start moving toward the building. Is it literally like a lava flow, is going to take it out. Well, if I didn't have a process to think about what's going on, well, I could have just sat there and then people would have been pretty disappointed. So, but, we had to immediately say, I need you to get a dozer down there. We need to start, regrading this area. We need to move the soil away from the building so it doesn't overtake it. We need to then regrade the area upslope to remove driving forces that are helping move this whole thing. And it took an entire day of work to actually get it to the point where the threat was reduced to minimal amount. And we had to return to the area immediately adjacent to the building, because as soon as we swept the soil heaving up there, within a couple of minutes, it was lifting up again. You could hear the ground moving. It was a very interesting experience. And so, that required some thinking on my part about, well, how is this thing moving in the first place, and where is it important to do some work, and how will that affect it? And then what else do we need to do? We needed to get, they had some temporary pumps in place from a couple of days before near the lake to bring water to the local communities. And I said, you need to get those pumps out of the way. And the next day, the land that they were on was in the lake. So they could have lost their water supply. I mean, these weren't life issues, but they certainly were life convenience issues and equipment issues. And so, it took quite a while to get that site back into shape, and we're still not kind of done. And now that the large event has occurred and subsided, and conditions are more stabilized out there, now there's a new threat, because what that movement left behind was another scenario for another chunk to come down later. So now we're trying to see if they can find funding to, enhance the project that we did the first time, which kept the building from being inundated, but won't keep it from another episode. So, there's all of these layers, and it's not. This was something much different than just the can you do a stability analysis on this slope? It became a living project, and it's still out there. So that's probably one example.
I appreciate you sharing that. I mean, for being a listener, it's an exciting example. But thanks for sharing that. So, when you talk about, you just mentioned projects, and when we talk about projects, there's processes and there's phases, and can you maybe describe some of an engineer's role on some of these project phases, such as permitting?
Yeah. I was able to present something that included this well at the AIPG National Conference a couple of years ago, and I was talking to presenting basically in the context of my oil and gas work out in Western North Dakota, and just kind of my intentions were to let people know that, hey, we can actually get involved much earlier on in your project at less cost to you, right? How much does it cost to drive 10 hours to get to a landslide, spend 2 days nursing it, and then, keep going with that versus having, casually gone out and done a reconnaissance, So, but we recommend trying to get involved with people at the point where they're planning, not actually building, because then they can make better decisions. We can help guide them, without the risk of committing to a certain area or getting into a hazard or something. So, permitting is just, if people are checking things out, like how much land do we need to acquire? Can we fit our project within the limits? And do we want this site? We've done reconnaissance just to tell people don't build here, find another place because it's obvious that there's a landslide here, So, and then if they are committed to that, then there's the design phase. So if you're intending to build a pad and you'd like to make cuts at 45 degrees and fills at, 34 degrees, maybe that works, maybe it doesn't. Let us help you do a design that when you build it, you have a better chance of having it work out. And as we keep going down the list here, the risk is higher because we're coming in after decisions have been made, after work's been done. And so hopefully it all works out. But, then we have an investigation, when we're, either investigating, exploring the site or coming in to look at something after the fact. But, construction, a lot of folks like our design recommendations, but then they don't want to invite us out to make sure that it's done right. That's another problem. And so we can do that. We can monitor things. We can monitor them proactively because there's a risk, or we can come in and monitor things after something happens and tell you, how bad is it? When do you need to bail out? And then mitigation is the last one. That's at the extreme when something really bad has happened, and then you get the call. So, the earlier on, usually the less it costs, or at least the work is more balanced, and you're mitigating risks from the get-go, and your chances of being able to walk away from the project without worrying about it are that much greater.
No, thank you for going through those. So, this might be more for personal interest, but, whenever you talk geotech, whether it's with someone preparing to take an exam or if it's with a geotech engineer that's been practicing for a while, the term seepage is always being thrown around there. So, under what circumstances should someone even be concerned with seepage, and if so, how is that addressed?
Yeah, so groundwater per se isn't seepage if there's not really flow in any given direction. So that's usually not a problem, other than if you're going to excavate into it or something. So seepage is something that obviously you're going to come in need to address if you're dealing with slope stability issues, design of levees and dams, things where there's going to be differential water surface from point A to point B. And so there's a lot of areas in the Western Plains that look high and dry, but there's actually granular layers and things that trap water that influence the slope stability, and may or may not be addressed if you're placing a fill against a bank that has seepage coming out of it. That water is going to weaken the material that you put against it. It's got no way to escape anymore, so it starts to build up and do things. So anytime you have layered soil systems, you have water traveling from point A to point B, exiting somewhere, and you're going to impact that exit, where your structure or your fills are going to be exposed to flowing water, where you're impounding water, and this could also be things like tailings basins, and anywhere there's free water that's going to want to infiltrate through your project, or you build something that ends up creating the seepage, is a problem. So anytime there's impounded surface water, or flow through your project or something is appropriate.
Makes sense. So, when it comes to maybe education or training, or just schooling as a whole, you always heard there's two, I guess, schools of thought or two different types of people, right? You had your people that were book smart, and then you had some people that were just they're street smart, or maybe we'll call it in our case real world experienced. So sometimes when people are either preparing for an exam or training for a new role or a new position, they read a book or they read a manual, but that isn't always painting the entire picture. So what I'm trying to get at is, you know, let's just look at engineering, or education in engineering. Um, how can educators infuse real world experience in education for engineers?
That's a great observation. In fact, I'm the street smart guy who became more educated. I have a degree in geology. I have my licensure, but I don't have a degree in engineering, or geotechnical engineering, civil engineering. So as a geologist, I got into the engineering world. Um, I can use my geology background, obviously, but there's a lot of technical things that I had to learn on the job. And so I actually had a guy, another engineer in my first company, after a couple of years, come up to me and he say, "I don't see you reading much," because everybody was telling me what to do. Just give them this amount. That's all they need. Or this is how much that costs. Or just do this. So I was content for a while to be just good at those things. I can write something, I can calculate something, I can just give them this number. But I never thought about why I was doing it. And so the street smart stuff is important because you need to, the technical, both for different reasons. The technical stuff makes you competent using the tools. You know how they work. You can think good about math. There's people that do that better than I do, with elaborate analysis and stuff. And but you have to understand, what are you putting into that? Where are you getting it? What does it mean? What's important again? And then you need to be develop some sort of like an artistic mind to think of how do I take this project of mine and spin it around in 3D and think about what's going to go wrong, or what's driving the technical needs, so that I do it the best I can. So there's both of that. So I kind of envy people that know what they want to do. They get into school, they study hard, they're really super smart at the stuff they know. They get their graduate degrees and things like that. And, but then some of them can stutter because they come out and the real world is different, because contractors don't care if you know how to, study something molecular with clays. They want a person who can understand and help them do their work better. So I've been playing catch up, and I still do. I still have to read. I still have to get geologic reports and documents relative to the new areas I'm going into and things like that. But you definitely have to have them both, because you can be caught not understanding how to apply what you know, then you can feel dumb, or you can kind of know what's going on, but not have the tools or use them, and then you feel dumb too. So, it's all of that. The other thing about education, though, too, is, again, going back to the questions, everything ties into learning and talking with people. Me helping my clients and civils and contractors understand what I do and why I do it helps both of us. I can bounce the things off of them. They can nod their heads and say, "Yeah, I get that," and then they can talk to me about how they do their stuff, and then then I can be a better consultant the more I know about them, and they can be a better partner. The more they know about what I do. So that education is super important, and and I think it's something that you do as a benefit to your profession is, don't just be smart and do your job. Get out there and share what and make everybody smarter. That's kind of the goal.
I appreciate you sharing the path. It's an interesting path you took. It also shows that you don't have to take a direct path. You don't have to, major or be an engineer or student to have fall in love and enjoy the industry as engineering. You can take a different route.
Well, you kind of have to now. I mean, I was grandfathered into taking the PE exam because I
Right.
have a geology degree, but now you do have to have the degree.
No, correct.
So
But
there's that.
yeah, but I guess what I'm trying to say is you don't have to know maybe right away the path that you want to go.
Yes.
You can get
Yep.
there maybe taking a longer
Yeah.
journey. But I do agree. You read a book, but like you say, you get out in the field and you're like, holy cow, I read about it in that book, but it doesn't look like it did in the book. If you're lacking that real world experience, you might kind of struggle on how to address that particular situation. So a combination of both is always great. Geology, engineering. So, what in the world is an engineering geologist?
That's basically it's just a specific title for a person that's geologically focused but applies it to engineering. So you have engineering geology and geotechnical engineering. So geotechnical engineering is more of the engineering of soils and in a general way rocks based on soil theory. Engineering geology is more of the application of engineering needs to a geologic situation. So those registrations, I have those in California and Oregon, where the registered professional engineer, the PE has and engineering geologist have to collaborate on a lot of projects where the behavior of rock masses and stability from a geologic standpoint is critical to the solution of those problems.
I appreciate you sharing that. So, Charles, it's been a great time chatting with you, and we're coming to an end here today. But is there any words of wisdom or last parting? Not parting thoughts seems so final, but any last words you want to share with the audience for the day?
Yeah, well, yeah, a couple things. One is learn from the failures, explore those, and share them. Because they're not something to be hidden away. We all learn from those. But I'll pass along if it's okay. There's
Sure.
Lawrence Gonzalez wrote a book called Deep Survival about people in situations where they have to save their own lives. And this is a little extreme from an engineering standpoint, but he had what he calls the rules of adventure, and I like these because you can apply them to anything. And this is about saving your life, but it's also about, I think, project competency. First one is perceive, believe, then act. You take a look around, you assess the situation, you understand what's going on, and then you make decisions. Second, avoid impulsive behavior. Again, patience, observation, thinking, and then and this comes in where you have clients and people that are putting pressure on you to come up with a decision or something. Third, know your stuff. So read the books, get your experience, know what's going on technically and professionally, in terms of interaction. And that's something that examinees should be thinking about in their career as they're already developing. Fourth one is be humble. You're never going to know it all, and you're never going to be in a situation where you're just, I've been here before, I've done this. If you're really growing, you're going to be seeing new things all the time, and some of them might be scary. So apply those other rules. Fifth one is don't fall in love with your plan. You don't, things change, and you need to have checkpoints where you proceed, and then you, review, reflect, and respond with something somebody said. So each time you get there, you determine, am I okay? Do I need to change something before I move on? So there's that. And then finally, there's when in doubt, bail out. You don't have to keep digging the hole. And there's times when it's appropriate either to say, hey, I don't belong in this situation. Somebody needs to help me. Somebody needs to take over, or this isn't a good situation. We need to get out of this or not take it. You have choices, and you need to balance, those choices with, your skills and your risks and all of those things. So Yeah. Anyway, I'd recommend the book too.
No, I mean, there's some great words to live by, not just for survival, but I can see, like you said, you can use them in just everyday life.
Hmm.
How many times do we come across something that's not even that serious where we make a decision before we even take the time to look around and see what's really going on?
Yeah.
Um,
I tell people to have a Rolodex, if some of the younger people know what that is anymore. But you have a process, and it kind of includes everything that you might need to do. And even though it seems cumbersome, if you go through that every time on every job, simple or complex, it's easy enough to just flip through it, check off the list. I don't need this, don't need this. But if you're consistent in that process, and in the things that you have on your checklist, you're not going to miss stuff.
agree.
No matter
Agree.
what.
I haven't heard the term Rolodex in years, but I'm old enough to remember what it is. I probably had a couple growing up
Yeah.
as well, but everyone's probably thinking, "What the heck is Rolodex?" They're Googling right now as they're watching this podcast. So
Nice.
uh, it was a great tool. Um,
Yeah.
One of the first organizers. But Charles, I appreciate you coming out here. I'd love to have you back. There's so many other things I'd like to talk to you about. So if you'd like, we'd love to have you back on here and we can chat some more and get into some more of these exciting topics that is engineering. For the
Amen.
rest of you out there, I want to wish everybody a happy holidays. And before I let you go, Charles, you're from a cold climate, so you might have some different Christmas-like traditions up in the colder weather. You want to share what you'll be doing for the holiday season?
Uh, well, I need to get more lights. I know that. I don't necessarily have anything specific in terms of foods or other crazy traditions, other than just getting the lights and decorations up. But I'll admit that we're all bummed out in Grand Marais here because World's Best Donuts closed for the season, and we're gonna miss those. So
Sounds good, Charles. Hey, for everyone else, again, happy holidays, Charles. We'll be having you back here again shortly, and thanks for coming out and spending some time with us.
yeah, thank you, Chris.
All right, thanks, Charles. Take care.